what do you mean by realization of system? Realization of system is obtaining a network corresponding to the given difference equation or transfer function of system. Now, how this is performed? First, this difference equation has to be converted into algebraic equation in Z domain. So, you will convert this difference equation representation into algebraic equation using Z transform, and each term of that equation is represented by suitable elements. Now, for representing this in a network form, we are having three basic elements. Now, these three basic elements are, first one is known as an adder, second one is known as constant multiplier, and third one is known as unit delay element. Now, we will see one by one. First, let's see what is meant by an adder. So, adder is an element used to add two or more signals. This is an element, this is a basic element used to add two or more signals. So, if you have two signals, let it be x1 of n and x2 of n, then these two can be added together with the help of adder, which is represented like this, and then output will be x1 of n plus x2 of n. Similarly, you can represent this in Z domain also. So, I will represent the Z transform of x1 of n as x1 of z, x2 of n as x2 of z. So, now if you pass this x1 of z and x2 of z through this particular adder, you are supposed to obtain the sum of these two signals. So, that is x1 of z plus x2 of z. So, this is an adder. This is how you represent an adder. Now, second one is known as constant multiplier. Now, these are the elements that we use to convert this difference equation into a network form. So, second basic element used is multiplier, constant multiplier. Now, constant multiplier, it is used to multiply the signals with a constant. Now, this is represented using this symbol. So, let k be a constant. So, if you have signal x1 of n, when it is passed through the multiplier, what you are supposed to obtain? At the output, you are supposed to obtain plus or minus k x of n, or if it is represented in z form, that is x of z, when it is passed through the constant multiplier, output will be equal to plus or minus k x of z. Now, the third basic element is unit delay element. Now, unit delay element, it is used to delay the signal passing through it by one sampling time. Now, delay is normally represented as a block containing Z inverse. So if your time domain signal x of n is passed through this delay element, this is delay element, what we are supposed to obtain at the output is x of n minus 1. Now if you are representing it in the Z domain, that is x of z, then you pass it through the unit delay element, you are supposed to obtain is z minus into x of z. Now this is just the transformation x of n minus 1 in time domain will be represented in z domain as z inverse x of z. So you can take it like that also. So these are the three basic elements that will be used for representing a difference equation into a network form. So three basic elements are the first one is adder, we have seen the representation. Second one is constant, multiplier, and third one is unit delay element. So with the help of these three elements, we can represent any difference equation into a network form. Now let's see one example how this is represented. Now let's take one example. Let a discrete time system be represented by this particular differential equation, that is y of n is equal to 0.5 y of n minus 1 plus 0.8 x of n plus 0.4 x of n minus 1. Now what you have to do first, you have to do, this is the difference equation representation. This is similar to differential equation representation in continuous time. Here we are dealing with discrete time systems. So discrete time systems will be represented using difference equation. So this has to be converted into algebraic equation using Z transform. So Z transform of y of n can be written as y of z, that is equal to what? 0.5 y of n minus 1 when it is converted in Z domain, it will becomes what? Z inverse y of z plus 0.8 x of z plus 0.4 z inverse x of z. Now you have transformed your difference equation representation into algebraic equation in Z domain. Now let's see how this is realized into a network. Now you know x of z is always the input and y of z is the output. So let's write x of z at the left side and y of z here at the right end. Now let's start from x of z. Okay. Now just see the term, whether there is any term which is having x of z. So here you have 0.8 x of z. So the multiplying factor or the constant is 0.8. So just add a constant multiplier with the value 0.8, and what we are supposed to get is 0.8 x of z. Now the next term you are having is z inverse x of z. Okay. So when it comes to z inverse, you have to take the unit delay element from this side, because here you are having 0.8 x of z, but you need 0.4 z inverse x of z. So let's add a unit delay element here, z inverse, and what you are supposed to obtain at the output is z inverse x of z. Now you multiply with your constant 0.4. So you have now 0.4 x z inverse x of z and 0.8 x of z. Now these two, all the x of z terms has to be added together. So you have now here what you are having is these two is coming, that is 0.8 x of z plus 0.4 z inverse x of z. Now one more term you require 0.5 z inverse y of z. So what from y of z you have to take z inverse. So what you are supposed to obtain at this side is z inverse y of z. You need to multiply it with constant 0.5. So just multiply it with constant 0.5. Then it has to be added with the output coming here. So again you have a adder. Okay. Yes, this is the realization of this particular difference equation. So you have y of z is equal to z inverse 0.5 z inverse y of z plus what is coming here? It is 0.8 x of z plus 0.4 z inverse x of z. So this is the basic method of representing a difference equation into a network using three basic elements, that is adder, constant multiplier and unit delay element. Now from the idea of this we are going to realize IIR system and FIR systems.